Hello everyone, I hope you all are doing very well. Let's see today's daily challenge on Leetcode and we will try to solve it together. So let's see the problem statement at first. You are given an m cross n matrix. Initially, you are located at the top left corner of the matrix, that is 0, comma 0. And in each step, you can move only right or down in the matrix among all the possible paths starting from the top left corner and ending in the bottom right corner. Find the path with the maximum non-negative product. Okay. Uh, and if the product is negative, then you need to return -1. So you need to find the maximum non-negative product, and the product of a path is the product of all the integers in the grid cells visited along the path. Okay. So let's say if in this example, if you are traversing this path of -1, -2, -3, -3, -2, this path, then this will be the product of all these numbers possible. Okay. And if you try to see, there are many examples, and this is actually a very uh, common grid DP problem, okay, which we also have talked about in the earlier. So we will also revisit this once again from the very basics. And yeah, definitely try this problem first on your own and then only continue watching the video. Okay. So whenever you are told, whenever you are given this kind of grid and you are asked to go from the something from the top left to the bottom right, uh, in a grid, okay, with numbers in the grid, and you are, let's say, asked to maximize the sum or minimize the sum or something like that, you should definitely first try to give grid DP a try. So the thing is that if you are starting from this cell, you have and if you want to go to this cell or this cell, you have only one possible path. Okay. So you try to fill whatever the product. So only if only one possible path is there, then the product will be nothing but, if this is A, this is B, this is C, the product here will be A, B, C, A into B into C. So there is only one choice. So these are the base cases along the rows and along the columns, which you can easily fill. But whenever you are asked to, let's say, find this cell and what is the minimum product from this to this, so there can be various possible paths. There can be like this, it can be like this, okay, it can be like this also. But always you will go from this cell to this cell or this cell to this cell. Okay. So if you know the answers for these two cells, you can easily calculate the answers for this. Okay. For instance, you might think that if we want to just store the maximum value, that should be working. So what do I mean by this is that, let's say, talk about this point. Okay. This point in the grid, the second row and the second column. You can come to this point from two possible positions, and you already know the answers for these positions. Okay. Now let's say the answer here is xy and here it is pq. Okay. So, and let's say the answer here is t. So you have two possible products, xyt and pqt. Okay. I hope you do understand. Let's say here it was x and y, and somehow x, if you, let's say, x equal to p, you are telling, and here it was q. So it will be q over here, the product will be q over here. Okay. And whenever you are coming to this, you have two choices. You can come via this or this path. Both will give you two options, and you can simply store the maximum of these two options. Okay. So the thing is that, if, let's say, there was something like in this grid, it was 2, 3, 5, 6. Okay. So you see that in this cell, when you are coming to this cell, this is nothing but 6, 2 into 3, the possible product. If you are coming from 2 to 5, it is nothing but 6. Okay. It's nothing but 10. Okay. And now when you are coming from this and this, they have two choices. You have 6 into 6, which is 36, and you have 6 into 10, which is 60. So the maximum among them is 60. So till now, the optimal possible path is nothing but from left to right. So if you are in the cell ij, okay, you can generalize it by saying that you can only come from the cell I minus 1j or ij minus 1, something like that, whatever the convention you are telling. So yeah, you can tell me like that, and essentially you can just tell that till what now, whatever the answer it has been over here. So if you call that a dpi minus 1j, okay, multiplied by grid of I minus ij, grid of ij. This is one possible. This is one possible product which you have, grid ij, and you want to take the max of these two, I j minus 1 into grid ij. Okay, so these two are the possible things, and you want to take them essentially the max of this. So dpij, you might think that dpij is nothing but this whole thing, this whole equation, max of dpi minus 1j multiplied by grid ij, and dpij minus 1 multiplied by grid ij. So I hope the logic you get it very easily, and this is only the thing which you might be doing. Okay, but let's say you had some negative number. Okay, so what do I want to say, that consider this exact same example, uh, and let's consider it was minus 2 this time, 3, 5, and here it is minus 6 somehow. This is the thing. And when you are storing this, instead of 6 it will be minus 6 now, instead of 10 it will be minus 10 now. Okay, when you go from this cell to this cell, now when you are coming to this cell again, you have two choices to come from the minus 6 cell to minus 6, or from minus 10 cell to minus 6. Okay, so you have two choices. Okay, and this time also, if you see, since you had this negative sign, you had 6 into 6, minus 6 into minus 6, which is 36, and 60. Okay, you have this. But let's say, mm, let's say this sign was also not negative, but it was also positive. Okay, then you see here, if you put minus 6, and then in here if you put minus 10, then what will happen? Then what is going to happen? If you see, if you multiply this minus this 6 with 10, it becomes minus 60 now, and it becomes minus 36 now. Which is the greater number? It is 36 is the one which is the greater number. Okay, minus 36 is the greater number. So this time you see, since there was a negative number somewhere, you want to essentially choose the number which is right now greater. Okay, which is also right now greater. So you might think that, hey, I will also uh, select the maximum number over here. Okay, but if let's say you have a negative number on the cell on which you are currently at. Okay, so if you have negative number over here, and let's say the after multiplication also this number was very much negative. Okay, something like minus x and something like minus y, and if you only store the maximum value. So let's say you had two choices, minus 2 and minus 5 to store, and let's say you had here two choices, minus 3 and minus 6. Now you might be thinking that out of these two choices, let's say I somehow ended up in storing the maximum number only, the maximum number out of these two, as in every cell I am doing max of this xy. Okay, max of the two choices I am doing. Okay, then in this case you will end up in choosing 3 or minus 2, and then when you have the choice to come to this cell, you will notice something is that you are essentially now calculating 6 and 4. Out of these two, you are calculating the maximum number. Why? Minus 2 into minus 3 only you are having, and minus 2 into minus 2 is the thing only which you are having. So out of this 6 or 4, you select the 6. But there was a more negative number, more number possible, right? So how can that be possible? If you would have also kept this minus 6, you would have ended up in multiplying minus 6 into minus 2, which will be 12. Okay, so you are missing out that case. You are missing out that case. So basically, the thing is that, instead of just storing the maximum value, okay, instead of just storing the maximum value in your DP whenever you're doing, instead of max of XY, you store both the minima and the maxima. Okay, because the thing is that whenever you are having a negative number, okay, so let's say your current number is negative. Okay, and your previous multiplication was also negative, so you want a number as small as possible, right? Because uh, let's say if you have a very large number, and if you multiply that with a negative number, that becomes a very large negative number, right? So you do not want a large number in that case. In that case, you want a smaller number. So whenever you are multiplying the current grid, whenever it is negative, you want a smaller number. You want to select the one which is the global minima and not the global maxima. Okay, so that's why instead of one value, instead of storing just the one value in the DP, you want to store two values, max and min. In that case, you can also select a DP of pairs, or also you can just do mm, whatever, like just you can make two DPs, DP max, DP min, and you can just update instead of this only maximum, you can update both the maximum and minimum. And if the current grid, if the current element in the grid is less than zero, okay, if it is less than zero, if it's a negative number, then you choose the minimum number, because a negative number, if you want to maximize this with x, you want to be x to be as minimum as possible, not as maximum. Okay, so yeah, that is the thing, that is the thing which this problem has in unique in compared to the other DP on grid problem. Okay, and if you are having trouble in understanding this kind of logic in DP on grid, that it comes from the previous two cells. I hope it is now very much clear and how to think on this. So let's see, let's try to code this out, the problem. So we have an m, which is nothing but the number of rows, and we also have n, which is nothing for but the number of columns. Okay, and you want to store two kinds of DP, right? So you can store it in this way, DP max, where you will end up in storing the maximum values, or DP min, where you will end up in storing the minimum values. Okay, so how to initialize this? You can initialize it in this way. I hope you know this basic initialization of a simple 2D DP. Okay, and yeah, you have it. So when you are storing the minimum value, you want an int max to be present. Okay, and when you are storing the maximum value, you want the int min to be present. I hope you can make this without this also. And yeah, I hope you can just keep this as 0 also, because there will be no issues. There will be no issues. There is a modulo also which we need to use. So it is 1e9 plus 7. And yeah, now comes for the multiplication part. I plus plus. So let's traverse through the first column instead. Okay, so I am making here the column row value variable. Okay, in order to iterate through the first column. So you have something like dp of I 0. Okay, this is my first column. And what will be this? What will this become? This will become nothing but dp of I minus 1 0 multiplied by grid of ij. Okay, I0. So what I am doing in this case, first I am traversing through the column. Okay, so in the column, as I told you, there is only one path. So this value will be nothing but the grid value, okay, multiplied by the previous dp value. Okay, so the previous dp value multiplied by the grid value. That's what I'm just doing. And yeah, you can put the modulo over here also. So I will also try to put the modulo, and if possible, I will also try to make this long, because if by chance the resulting might be long. So yeah, we have this. And for this, you see, you should start with I equals to 1, because you are accessing this I minus 1, right? And the first cell in the DP, you can just simply store it as DP00 is nothing but grade 00. Okay, that is only the first element. So that is only the product. So again, the same thing you did for the first column, you can now do it for the first row. Okay, so you can go for the other dimension. j less than n, j plus plus. Yeah, you could have kept it I also, but yeah, we use the other dimension as j generally as a convention. So it will be from dp j or j minus 1, grid 0, j. Okay. So I hope this is very clear. And now what you will do, you will have a for loop ij. Both of them will start with 1 this time because you have now filled both the first row and the first column. So these are the base cases of the TP which you have already filled out, and you want to start from this cell and fill out everything over here. Okay. So 1 comma 1 is the position which you need to start. So I1 and J will also start from 1. Okay. So yeah, after you have this, one thing you must notice that I had made two DPs over there. So I will also want to store something like this. Okay. As of now, this DP min and DP max will have the same value. Okay. So we'll have the exact same value. So you can just write max and min everywhere. So this first DP is nothing but max, and the next one uh, is nothing but main. Okay. So you just store a main over here. Okay. So after doing this, what you can do, uh, you want to, for every cell, you want to store the maximum as well as the minimum cell. Okay. So what you want to do, you want to try out all possible cases. So uh, dp max ij, okay, is nothing but max of uh, dp max I minus 1j multiplied by, you want to multiply it with grid of ij, right? Okay. But now I want to see if the value is greater or smaller. So as I told you, if the value is currently negative, then our parity will shift. Okay. So if thing is that if grid ij, this value is greater than or equals to 0, then we will do something, and otherwise we will do some different thing. Okay. So if the current value is greater than 0, then dp max will be nothing but, we can update this dp max like this, and uh, dp minimum also we can update it like this. So this will now be minimum of this uh, dp min I minus 1j. So yeah, and ij minus 1. This, another thing which you also need is ij minus 1, right? So this same thing, but it will be ij minus 1. Maximum among these two choices only, right? So this is nothing but ij minus 1 and dp min of again ij minus 1 multiplied by this grid ij. Okay. Now one thing is that again you need to put the modulo after doing long long. So I am doing using the long long again and again. So I will just do and hash define ll long long over here. Okay. So that I can just use this ll wherever I want to place a long long. So I made this one a long long value, and then for having the module I just place the modulo mod. Same for this I will do, and yeah, the exact same thing. And again, if you try to see, I will also do this ll In the exact same thing I'm doing, and I hope there is no doubt in this. Okay, so once we are done with this, if it is else case, we have to do something else. Why? What is the thing is that now the maximum and minimum parity will shift. Okay, what do I mean by parity being shift? So first, let me paste these values here. Yeah, after I have it, uh, as we saw that whenever a number is negative, in order to store the maximum value, we need the number which is not the maximum, which is the minimum. Okay, so minimum from the previous cell we will take and multiply if we want to store the maximum value. Okay, so for storing the maximum value, we will take from dpmin. Okay, that is the same minimum from the previous cell, and for again for vice versa, for storing the minimum value, I will take from dp max. Okay, so that is what. So if I want to store the maximum value, I want to maximize it, I will, since my current number is negative, I will take it from the dp min. Okay, and if I want to store this minimum value, I will take it from the dp max, because my currently parity is shifted. And I hope with examples you have understood why we do this. And at the end, after you have calculated everything, you can simply return your answer. But here there was one question, that if the maximum non-negative product is more, this you need to return -1. Okay, so if you see, uh, if the maximum product is negative, you return -1. So you might think that you will have to return uh, dp max of m-1 n-1. You can think it in this way, but if this whole thing is negative value, you need to return -1. Okay. But now one thing is that you are doing this modulo every time, right? But if happens to be a negative number, uh, then this modulo won't work. Okay. So notice the numbers are here really small. So the thing is that if you use long, you do not need a modulo at all. So m and n are only 15, and grid max can go till 4. Okay, so the thing is that uh, if m and n, these both values go up to 15 only, your traversal path will be nothing but 15 plus 14. So it will be 29. I hope you can understand what this length is. 15, this length is 15, but there is a repeated cell, so 30 minus 1, it's 29. And every time, if you, even if you get something like 4 4 4, every cell is 4, that is the max it can go, right? It can go from -4 to 4. Then you will end up in having 4 to the power 29, which is nothing but, if you also approximate it to 2 to the power 60, you can store this value in a long value. Okay, so 2 to the power 10 is nothing but 1e3. Okay, and 2 to the power 60 will be nothing but 1e18. So this 1e18 value you can store in a long. Okay, so after storing it in a long, at the end only you can just do a modulo. So you do not need to do modulo in every step actually, because that might cause an issue. Okay, I hope you do understand why I am telling it will cause an issue, because you do not know the current number you are storing is negative or positive. Okay, so a negative number, if you have -2, you cannot perform a modulo. Okay, so do better not to use the modulo, and just use a long value. Just use a long value everywhere you see. So yeah, so I will just replace this with LL, this with also with LL. Yeah, in all the vectors, I will just use a long because it will fit in the long no matter how high the number is, because the end numbers are small. So yeah, and uh, just remove all the mods. Okay, so yeah, this mistake I did, and just remove all the mods. Yeah, you can also initialize this instead of writing this two times. You can also initialize it in this way. It is completely fine. Okay, so yeah, it will just look a little bit neat. So yeah, you can store it in this way. And yeah, again, the same thing over here. You have to remove all this long and module. Okay, so just get rid of that quickly. So yes, after you have gotten rid of all these modulo value, you can just check that if this current value, if this dp m minus 1 n minus 1, if it happens to be less than 0, then you can return minus 1, okay, as is told in the question. If it's less than 0, return minus 1, else you can simply return this dp m minus 1 n minus 1. And you want to, since you want to return the max value, you need to take care that is dp max. Okay, so yeah, that is all for this problem. I think if I try to submit this, will it work or it will give some issues? Yeah, we have this sign over here. Let's try to debug this if it does give any error. So this is of the type of this only. So yeah, you again have this extra parenthesis over here. So yeah, I will try to just remove that. Let's see now if it works. So yeah, if now it works just perfectly fine. And if we try to submit it or for all the cases, I hope that will also work fine. So let's see. Okay, so yeah, over there we are getting a wrong answer. So yeah, if it is dp, I need to do the modulo operation, right? If it's positive, I will return this modulo mod. So yeah, if I try to submit now, uh, let's see if it will work now. Yeah, it did work fine, and we also have a pretty good runtime as well as memory complexity. Yeah, that's all. That's all for this problem. I hope at least the concept was very much clear, and also this implementation is also not very difficult to understand. So yeah, that's all. That's all for this problem. If you have any doubt, you can ask me in the comment section. I will meet you in the next video. Till then, thanks a lot.